learners, welcome to today's lesson. Today we are going to look at Form 4 Mathematics under Longitudes and Latitudes, and we are going to read the question together straight away. The question reads, an aircraft flying along the parallel of latitude from P 60 degrees north, 15 degrees west to another point Q, which is located 60 degrees north, 30 degrees east, took 4 hours 10 minutes. Taking the radius of the earth to be 6370 kilometers, calculate to the nearest whole number the distance covered by the aircraft. Roman 2, the speed of the aircraft. So let us look at part A first. Let us look at the solution for this question. We have our point P here, which is 60 degrees north, 15 degrees west. We also have another point Q here, which is 60 degrees north and 30 degrees east. We are supposed to calculate the distance between P and Q. Before we calculate the distance, we need to ask ourselves, are these 2 points lying on a great circle or a small circle? How do you know that they are lying on a small circle or a great circle? If they share the latitude, because the first one is the latitude and the second ones are the longitudes. If they share the latitude, then you should know that the 2 points are lying on a small circle. Then once you know that the 2 points are lying on a small circle, you are supposed now to calculate the distance here. How do we calculate the distance between any 2 points that lie on a small circle? Distance between any 2 points that lie on a small circle in kilometers is given by alpha, or let me not use that alpha there. Let me say we use what we call the longitude difference over 360 times 2 times that is 2 pi r. Then we talk about cos latitude. So in this case we can say, let us replace our longitude by the alpha and the latitude position, in this case by what we call theta. So in short, distance between P, Q in kilometers is going to be equal to the longitude difference is given the alpha over 360 times 2 pi r, then we multiply by cos theta, and our cos theta is the latitude position in this case. So what is our alpha here? Our alpha is the longitude difference. If one point is to the west, another one is to the east, we add the two so that we can find the distance between them, and in this case our alpha is going to be 15 plus 30, which gives us 45 degrees. Then our theta here, you look at the position. The 2 points are raised 60 degrees above the equator, and therefore the latitude position for these two is going to be equal to 60 degrees. In this case, distance between P and Q will be equal to alpha, which is 45, divided by 360 times 2 times 22 over 7 times the radius of the earth has been given as 6370 times what we call the cos of the latitude position, and the latitude position is 60 degrees here. So when you work out the question there, it is going to give you what? If you work out the question, it is going to give us 2502.5 kilometers, which is approximately 2503, because we are supposed to give our answer to the nearest whole number. In this case, our answer here, our answer is going to be equal to 2503 kilometers. That is the answer to part A of the question. Then going to part B, that is part A Roman 1. This is part A Roman 1. Then Roman 2 of the question. Roman 2 of the question. We are supposed to calculate the speed of the aircraft. How do we calculate the speed? Speed is always given by distance over time. And remember, our speed is going to be equal to the distance that we have calculated here. And the distance we have calculated is 25.03 kilometers divided by the time. And we were told that the time is 4 hours 10 minutes. 4 hours 10 minutes is going to be 4.10 divided by 60. It's going to give us 0.16, and therefore it is going to be 4.16, correct to 2 decimal places. And if you take 2503 divide by 4.16, it is going to give us 601. This one is going to be 601.68, but to the nearest whole number, this one is approximately 602 kilometers per hour, and that is the speed of the aircraft. Part A has been solved. Going to part B. Part B reads, the aircraft in A above flies from P to R, taking the shortest route possible. If you hear of the word shortest route possible, shortest route is usually through a great circle, but we are going to find how. Calculate to the nearest minutes the time it takes to complete the journey. So what we need to do is that we already have time, we already have the speed. What we need is the distance between point P, and therefore we know P was 60 degrees north and 15 degrees west, and our R is 30 degrees north but 15 degrees west. It is very clear that P and R lie on a great circle. How do you know that two points are on a great circle? If they share the what? No, I'm sorry. R is 30 degrees north, 15 degrees west. This is 30 degrees. So you realize that the only difference we have is on the latitudes, but they share the longitude. If 2 points are sharing the longitude, that is an indication that they are on a great circle. So what are we supposed to do first? We are supposed to get the distance between PR. So distance PR, since they are on a great circle, to calculate the distance between any 2 points on a great circle, we say the formula is theta over 360. We multiply by twice by r. In this case, our theta here is going to be equal to the latitude difference. And the latitude difference, if they are not north, we subtract. South, south, we subtract. But if they are not one north, another one south, we add so that we can get the distance between them. In this case, our theta is going to be 60 minus 30, which gives us 30 degrees. And therefore now, to get our distance, we are going to take our theta, which is 30 degrees, divide by 360. We multiply by 2 times, 22 over 7 times 6370, and this one is going to be in kilometers. So if you work out that, it is going to be equal to 30 divided by 360 times 2 times 22 over 7 times 6370, and this one is going to be 3336.7, which is going to be 36.666, which is going to be 7 kilometers, correct to the nearest whole number. Once we have the distance and we are supposed to calculate time, it means the aircraft flew from P to R using the same speed that we have already calculated in Roman 2 of part A above. In this case, if you want to calculate the time is usually given by distance over speed, and in this case our distance is 3337. You divide by 602, and this one here is going to be equal to what? This one is going to be 5.543, and in this case these are hours, but we are supposed to give our answer to the nearest minutes. That means we are going to convert, these are 5 hours of course, but we have to calculate the 0.54 into minutes. So if you take 0.54 times 60, we are going to have 32 minutes 4 seconds, and in this case we don't consider the seconds. We are going to have 32 minutes, and that is the answer to that part of the question. Going to Roman C of the question, allow me to wrap one side so that we can be able to do it. If the local time at P is 10:00 a.m. on Monday, calculate the local time at, for example, Q. Again, this question is very easy since it's talking about time. Let me do away with this part, then do part C here. For us to be able to do part C, we need to know that when it comes to time, the Earth rotates in 24 hours through 360 degrees, and we want to know for every 1 degree how many minutes does the Earth take. So what we are going to do when it comes to time, what gives us the difference in time is the longitude difference. In this case, if I might draw a diagram here, assuming this is our prime meridian, we have our point P here, and point P is actually 15 degrees west and the time here is 10 a.m. We also have another point Q here, and the Q is to the east, and of course it means it is past the prime meridian, and we have been told this one is 30 degrees here east. So we need to calculate the time at point Q. Since Q is ahead of P, we are going to calculate the time difference in terms of minutes or hours, then add to 10 a.m. so that we can get the time at Q. So we know that our longitude difference here, since this is west-east, we are going to add, and if you take 15 plus 30, this one is going to give us 45 degrees. And we know for every 1 degree, the Earth takes 4 minutes. What about 45 degrees? 45 degrees will be equal to 4 times 45, which gives us 180 minutes. So if you take 180 minutes divided by 60, 180 divided by 60, this one gives us 3 hours. And therefore, to get the time at Q, time of Q will be equal to 10 a.m. You add 3 hours here, and this one here is going to give us, if you add 3 hours, this one is going to give us 1300 hours. Since this is past midday, we are going to take 1300 hours, we minus 12 hours, and that one is going to give us 1 p.m. the same day, which is on Monday. And that is how that question is done.